More than half a century ago, humanity accomplished the unimaginable, setting foot on the surface of the moon. The Apollo missions marked a monumental leap for our species, but those visits were fleeting, mere days spent under the harsh lunar sky before returning to the safety of Earth. Today, the vision is far bolder. With NASA's Artemis program, we are preparing not just for another visit, but for a new era, one in which humans will live, work, and build a sustainable presence on the moon. But the moon is not a welcoming world. It is a realm of silence, with no air to breathe, no atmosphere to shield against the sun's radiation, and temperatures that swing from blazing heat to bitter cold. To survive and thrive, we must bring together the best of human ingenuity, science, and international collaboration. So what exactly is NASA's plan to turn the moon into our second home? To decode this problem, watch until the end. A surprise awaits you. Subscribe to the channel now so you don't miss out on valuable knowledge, and join me on the journey of independent scientists. At the heart of this strategy lies the Lunar Gateway, a unique outpost that will orbit the moon in a near rectilinear halo orbit, a path that is both stable and fuel efficient. This orbit keeps the Gateway in constant view of Earth and provides access to the moon's most valuable real estate, including its mysterious South Pole. Unlike the International Space Station, which circles our own planet, the Gateway floats in deep space, serving as a vital bridge between Earth and the lunar surface. The Gateway is more than a way station. It will be a state-of-the-art laboratory, a place for scientific research, and a safe haven for astronauts venturing further than anyone has gone before. At its core are two essential modules: the power and propulsion element, which harnesses solar energy to generate power and maneuver the station, and the habitation and logistics outpost, where astronauts will live, work, and prepare for their missions. These modules are being developed not just by NASA, but by a coalition of global partners: the European Space Agency, the Japan Aerospace Exploration Agency, and the Canadian Space Agency, whose advanced robotic arm, Canadarm3, will help assemble and maintain the Gateway. So, how will astronauts reach the moon? The journey begins with NASA's Orion spacecraft, which will ferry crews from Earth to the Gateway. From there, specialized lunar landers will shuttle them down to the moon's surface, while the Gateway remains overhead, a lifeline and a launch pad for further exploration. This modular approach allows for flexibility, safety, and reuse, reducing the risks and costs of each mission. But establishing a sustainable presence means more than just landing on the moon. The real challenge lies in building a base where humans can live for weeks, months, or even longer. The key to this vision is location. NASA is targeting the moon's South Pole, a place of perpetual shadows and near-eternal sunlight. In the depths of its shadowed craters, water ice has waited undisturbed for billions of years. This ice is more valuable than gold. It can be melted for drinking water, split into oxygen to breathe, and even converted into hydrogen and oxygen fuel to power rockets for journeys far beyond the moon. To build a home in this harsh environment, astronauts will harness the moon's own resources. Gone are the days of fragile tents and temporary shelters. The future base will be constructed, in part, from the lunar regolith, the fine, powdery dust that covers the moon. Using advanced 3D printing technologies, robots will transform this regolith into sturdy walls and protective domes, shielding crews from radiation and micrometeoroids. Companies like Icon are already pioneering these methods, turning science fiction into reality. Some habitats may arrive as compact inflatable modules, launched small to save space, and expanded on the moon to create comfortable, spacious living areas. Once covered with a thick layer of lunar soil, these modules become fortresses against the relentless dangers of space. But survival depends on more than walls and roofs. Energy is the lifeblood of any lunar base, powering everything from life support to research equipment. Initially, vast arrays of solar panels will capture the sun's energy, especially in the polar regions where sunlight lasts for weeks at a time. But when the lunar night falls, or in permanent shadow, NASA is developing compact nuclear reactors, known as kilopower systems, to deliver reliable electricity day and night. Inside the base, life support systems will recycle water, scrub the air of carbon dioxide, and even grow fresh food in tightly controlled environments. Closed-loop designs will minimize reliance on costly resupply missions from Earth. By cultivating plants, astronauts can supplement their diets and help purify the air, bringing a touch of green to the grey lunar landscape. Yet every step forward brings new challenges. Cosmic rays and powerful solar storms threaten to overwhelm unprotected humans. The lunar dust is sharp and abrasive, working its way into every seam and joint. Temperatures swing from minus 173 degrees Celsius at night to 127 degrees during the day. Even the simple act of walking on the moon demands suits and equipment that can withstand these extremes. Psychologically, the isolation of living so far from Earth, days away from help, with only the distant blue globe hanging in the sky, will test the limits of human endurance and ingenuity. But the rewards are just as great. The moon is more than a destination, it is a proving ground. Here, we can test the technologies and strategies needed for the next giant leap, sending humans to Mars. Every 3D printed wall, every recycled drop of water, every experiment in growing food in alien soil brings us closer to surviving the years-long journey to the red planet. Beyond science, a lunar base could spark new industries, mining for rare elements like helium-3, a potential fuel for future fusion reactors, or even opening the moon to tourism and commerce. The Gateway and Lunar Base will stand as beacons of international cooperation, showing what humanity can achieve when we reach beyond our difference to explore the unknown. This is the Artemis generation's calling, not simply to return to the moon, but to stay, to build, and to learn. By conquering one of the universe's most unforgiving environments, we are laying the foundations for a future among the stars. The journey will be long and difficult, but the spirit of discovery that drove Apollo now propels us further than ever before. If you've watched this far, congratulations. You are truly a passionate scientific explorer, always persisting and conquering every challenge. Let's subscribe to the channel so we can keep on discovering together. Surviving and thriving on the moon is no longer just the dream of science fiction. It is the next great adventure in humanity's story. A chapter we are writing together with courage, creativity, and an unyielding desire to explore. As we look up at the moon, let us remember, this is only the beginning. The next steps we take will echo across the solar system, lighting the path for generations yet to come.